Today we're diving into the world of Python to build something super practical and fun, a simple calculator. This is a fantastic project for beginners as it touches on core programming concepts like user input, conditional statements, and basic arithmetic operations. By the end of this video, you'll have a working calculator that can add, subtract, multiply, and divide, and you'll understand how every piece of the code works. So let's get started. First things first, let's open up a text editor. I'm going to be using VS Code. You can save your file as calculator.py. Make sure you put the .py at the end. That's what makes it a Python file, or the text editor won't recognize it as such. Now, what do we need for a calculator? We need to get input from the user, the numbers they want to operate on, and the operation itself. I'm going to type that out here. So let's do print welcome to the simple Python calculator. And also print the operations available. We're going to make a variable num1 underscore str and set it equal to input. Enter the first number. We're going to make another variable operation and set it equal to input, enter the operation. And we're going to make a third variable num2 underscore str, which is short for string, and set it equal to input, enter the second number. Whoops. Okay, so let's break down these first few lines. Print welcome to the simple Python calculator. This is just a friendly greeting to our user, letting them know what the program is. For print operations available, plus minus asterisk slash. This line informs the user about the operations our calculator supports. For input, enter the first number. The input function is crucial here. It displays the text inside the parentheses to the user and then waits for them to type something and press enter. Whatever they type is returned as a string. We store the string in the variable num1 underscore str, which is short for string. Input, enter the operation. Similar to the above, we get the desired operation from the user and store it in the operation variable. And input, enter the second number. Finally, we get the second number as a string, storing it in the variable num2 underscore string. Here's an important note. The input function, which is just input with parentheses and something inside it, always returns a string, But for mathematical operations, we need numbers, which are integers or floats. So our next step is to convert these strings. Okay, on to type conversion and error handling. What if the user types hello instead of 5? Our program would crash if we tried to do math with hello. This is where error handling comes in, specifically using try except blocks. And before that, we need to convert our strings to numbers. So I'm going to type out the code for this real quick. First, it's going to be try colon num1 equals floats num1 str. Same thing for num2, and then except value error print invalid input. Please enter valid numbers, and then exit. Okay, let's dissect this new section. For try with the colon after, this keyword marks the beginning of a try block right here. Code inside this block is executed normally. If an error occurs during the execution of this code, Python will immediately jump to the except block. So this is the try block, and this is the except block. Alright, now num1 float, num1 str. With this, we're attempting to convert the string num1 str into a floating point number, which is a number with decimal places, using the float function. If the variable num1 str contains something that cannot be converted to a float, like the letters A, B, C, for example, a value error will be raised. With num2 float num2 str, we're doing the same thing. And for except value error, right here, this line catches a specific type of error, which is called a value error. If a value error occurs within the try block, in our case, if the float function fails, the code inside this except block will be executed, which is this code right here. So it'll print invalid input, please enter valid numbers. This friendly message informs the user that they made an invalid entry. And finally, we have the exit function. This function immediately terminates the program. There's no point in continuing if we don't have valid numbers to work with. By using the float function, our calculator can handle both whole numbers like 5 and decimal numbers like 3.14, for example. Okay, on to part 3, performing the calculation with conditional logic. Now that we have our numbers in the operation, it's time to actually perform the calculation. We'll use if, elif, or else if, and else statements to check which operation the user chose. So I'm going to type out the code for that now. First, I'm going to make a result variable. Now our if elif statements, or if elif else statements. And finally, I'm going to put the last print statement in here. Okay, so let's break down this crucial part. Result equals none. Here we initialize a variable result to none. This is good practice. If for some reason none of the conditions are met, result will still be none, preventing potential errors later. If operation equals plus, this is our first condition. If the operation variable is exactly equal to plus, the code inside this if block will execute, which is this code here. When I talk about the block, that means you can see it'll like start on this line, and then anything that's indented in the lines after it, that's the block itself. Okay, for what was the next one? Elif, or let me see. Yeah, so for Elif, minus um, that basically just means if the previous if condition, which is this if operation here, if operation equals plus, is false, then Python checks the elif, which is short for else if condition, and the condition here is operation equals minus, and then subtraction is performed with this block of code. And then it's the same thing for multiplication and division here. Well, for division it's a little bit different actually, because it has a special case that we added. Since dividing by 0 is undefined and will cause an error in Python, so we did if number 2 equals 0, like if we're trying to divide by 0, then we'll print error cannot divide by 0, and then we'll exit the this whole block of code. And then, so we still have the division function itself. We write else. So if the number's not 0, like we're not trying to divide by 0, then just do division normally. So result will equal number 1 divided by number 2. And then finally we have the else statement for this entire block of code here. And this else block catches anything that wasn't handled by the if or elif statements. If the user entered an operation that isn't addition, subtraction, multiplication, or division, this block will execute. And for this print statement here, we just inform the user of the invalid operation, and then we exit the program with this function here. So the final part is displaying the result. Once the calculation is done and assuming no errors occurred, we want to show the user the result. So this is an F string formatted. It stands for formatted string literal. F strings are a powerful and concise way to embed expressions inside or variables inside string literals. You start an F string with a F before the opening quote. So inside the F string, anything enclosed in curly braces or curly brackets is evaluated as a Python expression and its result is then embedded directly into the string. This makes displaying dynamic output very easy and readable. So if num1 was 10, operation was plus, num2 was 5, and result was 15, the output would be the result of 10.0 plus 5.0 is colon space 15.0. Notice how even if you entered whole numbers, the float function converts them to like 10.0 and 5.0. This is generally fine for a calculator. Okay, so now we have the complete code for our simple Python calculator. To run your calculator, just click this drop down menu. Well, first save your file, and then just click this drop down menu here and click run Python file. And in the terminal that pops up here, it's going to show you all text and operations that you put in the code. So just follow the prompts, try different numbers and operations, and test out the error handling by entering text instead of numbers or trying to divide by 0. I'll just show a basic test of operations real quick. So let's do 2 plus 2. Enter the first number 2. Enter the operation plus. Enter the second number 2. You can see that gives us 4.0. We could also do, let's say, 2 minus 2, 0. We can do, just for a very basic example, 2 times 2. Again, 4.0. And lastly, to test out the division, we'll do 2 divided by 2, which is just 1.0. Okay, and there's further possible enhancements. This is a great starting point, but you can make this calculator even better. Here are some ideas for you to try. One is looping. Make the calculator run multiple calculations without exiting. You could put the entire calculation logic inside a while loop that continues until the user types exit or something similar. There's also, you can add more operations like modulo, exponentiation, or even square root, which would require importing the math module. You can make it have clear output. You could format the output of the result to a specific number of decimal places using f-string formatting options like :.2f. There's functions. As your code gets longer, consider organizing it into functions. For example, you could have a calculate num1, num2, and operation function, which would look like this. That's what the header, like prototype of the function, would look like. And then there's user interface or graphical user interface. So for a more advanced project, you could use a library like tkinter or PyQt to create a graphical user interface instead of just a command line interface. So basically, meaning you'd have like a more visual calculator with actual buttons that you could press on it instead of it just running in a terminal. Alright, and there you have it. A simple yet functional calculator built entirely in Python. This project demonstrates fundamental Python concepts that are essential for any aspiring programmer. The concepts are user input, which is getting information from the user, type conversion, which is changing data types like from strings to numbers. There's error handling, which is gracefully dealing with unexpected input using try except. There's conditional logic, which is making decisions in your code using if, elif, else. And there's formatted output, which is presenting information clearly to the user. If you enjoyed this tutorial, give it a like, subscribe for more Python projects, and let me know in the comments what other beginner projects you'd like to see.